Okay, let's move on to 3+1 or 4-axis indexing. Very common use of this is what is commonly known in the industry as flip machining. So we're taking a part that has two sides and you're flipping it 180 degrees and machining it in two different directions. There's a part in the graphic that you see that has two sides. It's a profile of a face, and you can machine the top, and then you flip it over and machine the bottom side. And our system allows you to do this.
Okay, let's move on to the next one here. We're going to do flip machining, 3+1. Let's go ahead and load that part file. Okay, so when you get into 3+1, 3+2, you need to make sure that you have your machine set up correctly for the additional axes that you're going to use. So in this part, I have one setup defined. I have the work zero in the top corner of the stock, and we have your operations for that one side. And for the machine orientation, this is going to be a 4-axis definition, and it's going to be a table configuration, meaning the rotational axis, the 4th axis, is on your table and it rotates, and your spindle is up here vertically machining. So you just want to make sure that your rotational axis matches what's on the machine tool and matches the orientation of your part. So we got our 4th axis going in the positive X direction here, indicated by this icon arrow, and the part is oriented in that axis. So, and also you want to make sure that for, just for any standard 3-axis operations, we've got the stock on the outside, and we don't want to cut all our stock, so we've got additional control geometry here on the inside, as well as a circular shaft that goes through that will keep it connected to the part stock on the outside. So what's going on? Go ahead.
Don, I want to make a note here. One of the interesting things that you might notice is that plane that's running in the middle. That's a important thing to understand why we have that. We call that like a catch plane. So basically, when you're machining it from one direction, the cutter is not going to go below that plane. So that's why that's been constructed. That's a very useful thing to have. This will prevent the cutter from going below that zero. And then when you rotate it, the same thing's going to happen on the other side. It's going to prevent it from going below that particular part. But and then finally, you can come in and do a cleanup operation or a profile operation where you're cleaning out the silhouette to clean out that little piece that might be left, or a little material collar that may be left there. So
let's go ahead and create the rotate table setup for the side 2, and we're going to go on 180 degrees to flip it over, and just pick OK there. And we're just going to take the same. We don't need to copy the work zero, so we're just going to copy those, and we're going to put it in setup 2. And here's setup 2, and we're going to regenerate that. So basically all the same parameters, everything works the same as the top half, and then you're going to do the bottom half. Let's go ahead. We got time to simulate this, Joe? Let's go ahead and simulate all.
Plenty of time, Don. You're rushing a little bit, so don't worry. Slow down. We got 30 minutes almost.
Okay. That's doing the one side. Let's go over. You can see the other side. So basically,
as you can see, the final cut went around, and you're still leaving some material there. Yep. But you could go in and do a profile pass around that and clean that out.
So that's where the cylinder that we added to the part that went through the rotary axis. That's so that you don't remove the part completely from your stock material. So, I also want to mention here, we have all of these part files programmed, and each of our platforms, we've got them in Rhino 6 and Rhino 7, as well as Visual CAD CAM. 2021 and Rhino CAM 2021, and also in Visual CAM for SolidWorks. So if any of you want the actual part files, just drop us an email to support at MecSoft.com, and we'll be happy to give you a download link, and you can actually get the part files and practice with them. Okay, so that's 3+1 or flip machining.
Yeah, I think there was one recurring question was on that catch plane issue.
The what?
On the flip machining, the
Yeah.
catch plane.
Yeah.
Can you bring up that part, Don?
Yeah, we can do that. And that was the flip machining.
Right. Yes, so the question was concerning that catch plane. Was that something we program in our system, or is that something that needs to be done in the CAD system? So
yeah, that's something that you need to add. Well, you can do it both ways, okay? In your first operation, in your roughing and in your finishing, you can control your Z depths, you know, but it's a lot easier to just put the catch plane in there. You see we got it at the bottom of our cylinder. So the tool paths are going to roll over the part down onto the catch plane. Okay, so it's a lot easier if you just put the surface in there and the program recognize it automatically and accommodate for it. So you'll notice that in the first orientation, the catch plane is at the bottom of the cylinder. All of the the programs that you initially run, let's show these, are all based on that catch plane. Okay. So whenever you copy them to the second orientation, you don't need the catch plane anymore. The programs are already calculated. If you're going to make edits to it and have side 2 different, than side 1, then yes, you may need to move the catch plane to the other end of the cylinder. But typically, if it's a symmetrical part like this, both sides are identical, then you don't need the catch plane. You only need it in the first orientation because it's already built into the calculations for the second one. I hope that answers the question.
Yeah, I think the important clarification is that catch plane has to be built in the CAD system. It's something that we don't necessarily see it as something special.
And another thing about the surface, there's nothing special about the surface, and the surface didn't have to be contained to the box. If you just want to go in and just draw a rectangular surface, doesn't matter where the coordinates are, as long as it covers the area that you want to machine, that'll work.
Yeah, and another important thing is you don't necessarily have to do it only in flip machining. You can do it in regular 3-axis as well. So if you had a part that you wanted to make sure that the tool didn't go below a certain Z level, you just create a catch plane in that Z level, and then the tool will not go below that.
And for all of our, since all of our listeners are AMS subscribers, we have a very good video in our CamJam archive that deals with the use of catch surfaces. They go by other names. It could be called a guide surface, or could be called a masking surface, or a catch surface. Basically, they're surfaces that you model in that assist you on guiding the toolpath where you want it to go. So that's important, especially in mold machining and other applications where you really need precise control of where the cutter goes.
Okay, there's another very important question that I can answer this, Don. So the question is regarding collisions, the tool colliding with the part when we have multiple setups. How do we make sure that we handle that? In the 4-axis mode, Don, if you go to the 4-axis options, no, not there, 4-axis options, select the options, you'll see there's, this is one way. In 4-axis, if you're doing 4-axis index machining and with the table, there's this first checkbox. You can always retract tool to the tool change point before each table rotate operation.
Very good option.
Yeah, you can use that option and set up your tool change point in your machine. If you go to the machine dialog, Don, and
sorry about that.
Yeah, there is in the general parameter, there's a tool change point you can define there. That can be something that is specific to your machine. And what you can do is at every time that you rotate the table, you can make sure that you go to that tool change point. That way you're clear of the table rotation.
Yep. Mm-hmm.
So that's an important way of doing it. Very easy way of doing, making sure that you're not colliding with the table as you're rotating.
Yeah.
And at the same time, some of these can be programmed in the post also. In the post, for each rotation, you can specify a point to go to. And those can be programmed in the post-process generator also.
A very good safety feature as well, because you don't want to be standing in front of your machine and having a tool crash into your stock and pieces flying. So that's very good option.
Very good question. Thank you.